Alright, ladies and gentlemen, in this video we are going to open up a discussion of circumscribed angles. A circumscribed angle, just simply put, is an angle that is created by two tangents outside of the circle upon their point of intersection. Remember, a tangent is a line that intersects a circle once, and there's our point of tangency in both tangents. So this would be considered a circumscribed angle, or two tangents intersect at point B. The theorem that goes along with our circumscribed angles and kind of the point of this video, which is to utilize this theorem in a variety of different ways to find arc measures and angle measures, both of central angles, inscribed angles, and all the above. It states that this circumscribed angle ADB is equal to 180 minus the measure of my central angle ACB. But keep in mind, the central angle ACB also is equal to its intercepted arc. I just want to point that out there because a lot of times what we'll see is that we'll see that we give the arc and I have to make the correlation that it's equal to the central angle. Let's take a look at a couple examples. So first and foremost, for part A, kind of with the basics. In this case, we would say that the measure of angle ADB, the circumscribed angle, would be 180 minus the measure of angle ACB, the central angle. Well, x equals 180 minus 135, and so x is 180. Whoops, I guess it's the same thing over and over again. So just go ahead and just make it 45 degrees there. All right, but what about on part B? What about part B? I want to get rid of this right here. Here's my focus. My focus right now is going to be on my circumscribed angle. But think about what you want to know. All right, I want to challenge you to pause the video real quick and just think about what is the angle EJF? What type of angle actually is it, and what do you know about it? So right now, my circumscribed angle, okay, the measure of angle EHF is equal to 180 minus the central angle. And I'm going to create a central angle right in here. Okay? So minus the measure of angle EGF. But do we also agree that the measure of angle EHF is equal to 180 minus the measure of arc EF? How did I get that? Because the intercepted arc is equal to the central angle. Okay, so why is this important? Well, if the measure of angle EHF is 30 degrees, equaling 180 minus the measure of EF, what is the connection between EF and angle X, EJF? Well, X, EJF, is an inscribed angle. And an inscribed angle is half the measure of EF. So that means the measure of EF is twice the measure of EJF. So it's 2 times the measure of angle EJF. So 30 equals 180 minus 2 times EJF, which is X. So really, in the end, you end up getting, and I'll kind of just put some arrows here, we end up seeing that we subtract 180, so we get negative 150 equals negative 2x, and x in the end is 75.